for our first meal, how about a nice meat dish using this diced beef? It's nice to have tender meat, but sometimes we might have a tougher cut that's harder to chew. However, we can get around this using pineapples. By combining meat with pineapple, we can make it tender. Pineapple contains something known as bromelain, a mixture of tiny compounds known as enzymes capable of helping various chemical reactions. In this case, the enzymes help break down the meat's collagen, fibers that give it structure and make it tough. Bromelain works as soon as we add it, so try to add the pineapple right before cooking. Otherwise, bromelain will keep breaking down the collagen until the meat becomes mush. After adding the pineapple to the diced beef, add the remaining ingredients of chopped bell peppers and garlic. Then season with soy sauce, sugar, salt, and black pepper to taste. Make sure to mix this well once all the ingredients are added. Once all the ingredients are mixed, heat up a well-oiled pan until it's sizzling hot. It's vital that we get it hot enough so that the beef doesn't release its juices when we add it. Once it's hot enough, add our ingredients and stir fry until the beef is cooked through. And after that, the meal is done. It looks delicious, doesn't it? And it pairs nicely with a bunch of other dishes like Chinese cabbage and rice. Yum!
For our second course, we will be looking at the reaction that creates the delicious and crispy outside of some of our favorite foods. To illustrate this reaction, we will be making scallion pancakes. The official name for the reaction that causes the browning or crispiness of foods is the Maillard reaction, and it's a lot more common than you might actually think. First, before we get to the actual science, we'll make our dough. We'll first boil some water and then let it cool slightly. Once it's cooled off a bit, we're going to add the flour and combine it with the water. Be sure to add more flour or water to make the consistency soft and not sticky. Next, we're going to let the dough sit covered for about 20 minutes, and while that is resting, we can make use of this time and wash and chop the scallions. When the 20 minutes have passed, we'll then uncover the dough and roll it out into a giant square, and then add seasonings like salt and pepper, oil, and the scallions that we chopped up, and we'll put those right on top of the pancake. We'll then roll the dough into a really tight cylinder and cut into about 8-inch pieces. Once we've cut those up, we'll pinch both sides of each piece until you can't see the insides anymore and all you see is the dough. And we will then flatten those into like a pancake shape with our hands. Next comes the actual part where the Maillard reaction comes in. We're going to heat oil in the pan and make sure it's really, really hot before we place each pancake into the pan and let the Maillard reaction occur. Make sure to flip your pancakes halfway and then we can enjoy them. The reaction is pretty complex and has taken scientists a long time to figure out what exactly is going on, but recently they've figured a lot of it out. To sum it up, the Maillard reaction is many small, simultaneous chemical reactions that occur when proteins and sugars in and on your food are transformed by heat, producing new flavors, aromas, and colors. The reaction requires a few things, first and foremost of which is heat. The absence of moisture is crucial since this allows for greater levels of heat to cook your food, and the Maillard reaction can only occur at these very high temperatures. They're typically over 300 degrees Fahrenheit, so you won't want to put your hand anywhere near that pan. Next, we need to know a bit more about what makes up the food we are cooking. Proteins and sugars are needed for this reaction. Proteins are long chains of amino acids, and some of these proteins bond really well with certain sugars that are called reducing sugars. These are essentially simple sugars like glucose that attract amino acids at certain moisture and temperature levels, which we have here when we make our scallion pancakes. In the scallion pancakes, the sugars and the proteins come from the wheat flour. The reaction creates new molecules which then go on to react with other molecules over and over and over again. These newly formed molecules are edible pigment molecules called melanoidins and are the brown colored areas of the scallion pancakes you see on your screen. This reaction may sound complicated, but it actually is quite cool and is something that makes our food extra delicious.
Here we will be analyzing the thermodynamics behind the creation of ice cream. For this experiment, we will need vanilla half and half, sugar, salt, and a bag full of ice, as well as an additional plastic bag. We will start off by measuring 1 cup of half and half cream and putting that into an empty plastic bag. This is followed by measuring 2 tablespoons of sugar and adding that into the same plastic bag. Lastly, we're adding a half tablespoon of vanilla extract to complete the basis of the ice cream itself. Now here is where the science gets introduced. We're going to measure out 1/3 cup of salt and add it into the bag of ice. This is to contribute to freezing point depression. We will focus on 2 states of water here, liquid and solid. You want to try and get as much air from the plastic bag out as possible before sealing it and placing it into the bag with ice and salt. Next, we're going to begin to shake the mixture for about 10 minutes before we see that the ice cream mixture has become solid. I would recommend wearing gloves for this process because it can get pretty cold. But what actually is happening here? Well, I'll tell you. Normally, at freezing point, the energy released by liquid water freezing into solid ice is at equilibrium with the energy absorbed by ice when melting into water. When sodium chloride salt is dissolved into water, mixing with the outer shell of water around the ice, the salt ion particles get between water molecules, making it harder for them to align to crystallize into salt. As a result, the freezing point of water is lowered. What results is melted ice that is colder than 0 degrees Celsius, providing an extremely chilly environment for our cream mixture. In essence, the ice melts into water, absorbing heat, but doesn't freeze back into ice in order to release heat. Because of this, the temperature drops. The cream is shaken around in the below freezing water in order to cool down our mixture, and what ultimately results is this delicious homemade frosty treat.